The Titrator AT1000 series laboratory analysis systems are one-touch, automatic analyzers covering both potentiometric titration and Carl Fisher volumetric titration methodology. This Titrator series replaces the AutoCAT 9000 and previous Titrator units from Radiometer and Hach. The AT1000 is received with preset methods that can quickly deliver accurate and reliable results straight from the box, allowing anyone in the laboratory to immediately perform accurate and reproducible titrations. A Titrator AT1000 series system is composed of two elements, the application package and the titrator. The titrator is delivered pre-assembled for quick setup, and the application package includes specific elements to make it quick and easy for anyone to set up and operate a test without the need for any complex programming. There are 5 different titrators available on the AT1000 product line. The models differ according to how many burettes, pumps, and electrode imports are available. This diversity in models makes this product line able to accommodate a wide variety of applications. The AT1222 model was chosen for this training on features and benefits because it contains 2 syringes and 2 pumps. Looking at each component on this AT1000 titrator will highlight the advantages this product line can bring to customers, such as a small, compact, all-in-one system, measurement reliability and accuracy, easy operation and intuitive software, increased productivity, and better data management. For a titration to be accurate, the volume of a titrant being added or dispensed to the sample has to be precisely measured. The AT1000 utilizes a high-quality Hamilton syringe, also known as a burette, and a syringe motor with micro-stepping technology. AT1000 models are available with single or dual syringes. Each syringe has a built-in valve that can divert or stop flow from the syringe. This allows the titrator to utilize different titrants and have access to multiple applications and analyze multiple parameters. Purging the syringe to remove old titrant and air bubbles is performed through the software. The software is also able to track or schedule maintenance or replacement of the syringe and syringe components. The tubing for the syringes is pre-installed on the instrument. The direction of the titrant flow is easily recognized by the up and down arrows. The blue indicators on the syringe tubing are installed to indicate delivery tips and installed in the port with the upward arrow. Tubing is easily installed by simply screwing in the tubing connectors into the correct port until a click is heard. The procedure for each application will detail the appropriate tubing to conduct that titration procedure. The AT1000 series includes titrators with 1 or 2 pumps installed or with no pumps installed. The pumps are used to automatically deliver additional reagents that are required in the titration reaction and often buffer the sample. The reagents can be manually added when using a titrator without installed pumps and when the application software is edited from auto to manual addition. Purging the pump to remove old reagent and air bubbles is performed through the software. The software is also able to track or schedule maintenance or replacement of the pump components. Stirring the sample during the titration is very important for accuracy. The AT1000 has a built-in stirrer and sensor holder. The sensor holder accommodates a sample beaker with a stir bar that can lock into place and has holes to position the electrode and tubing in the correct orientation. The titrator is not received with any application software loaded. The software is loaded onto the titrator through a USB drive that comes with the purchase of an application pack. The instrument will prompt the loading of the application USB when powered on for the first time or if the applications have been deleted from the instrument. The titrator has 2 USB ports. The first port is located on the side and the second port is located in the back of the instrument. On the side of the instrument are electrode storage tubes to store electrodes when not in use for easy access. At the back of the titrator, the following connections are available: the power supply, electrode sensor ports, external propeller port, external pump port, RS-232 serial connection, Ethernet port, and the second USB port. The number of electrode inputs refer to how many electrodes can be attached to the AT1000. The electrodes are used to determine the endpoint of the titration reactions. The recommended electrodes are listed in the titration method and may come in the application pack. The legacy sensor adapter and holder is used in application kits that call for the use of a sensor that is not from the IntelliCal product line and has an M12 digital output connector. In this example, the legacy adapter is plugged into sensor port 1 and a BNC ISE electrode is connected to the adapter. The IntelliCal electrode sensor is received with the purchase of the application kit, and the model received depends on the kit purchased and titration to be performed. The electrode sensor, with its M12 digital connector, is connected into the back of the titrator in either the sensor 1 or sensor 2 connection ports. In this example, sensor port 2 is used. The titration software will recognize the digital electrode sensors connected. The software is also able to track and prompt electrode maintenance such as cleaning, calibration, and replacement. The AT1000 titrator has a large color graphic display and a keypad that is ruggedly constructed with icons that are easy to recognize and function commonly to a variety of other Hach instruments. The buttons include the following: a power key, selection key or soft keys, navigation keys, home key, and a printer key that is only functional when the printer is attached. Pushing this home key will cause the software to go directly to the main menu. Applications are loaded onto the instrument using a USB drive. The location of the loaded application depends on the model of the titrator. Titrators with more than one syringe will have 2 rows for applications. Other common operation icons are found on the home screen for easy access and navigation. These include data log, calibration, system settings, maintenance, and purge options. Interface icons are also provided at the top of the main menu that indicate what is connected to the titrator, such as a printer, USB key, sensors, and data file information. The first row will utilize syringe 1 and the titrant connected, and the second row will utilize syringe 2 and the titrant connected. Each row is able to load up to 5 applications. The titrant can also accommodate on the first row direct measurement applications such as pH and conductivity, where the titrator measures the pH or conductivity electrode attached. The AT1000 series stores the data from the last 100 samples and the last 10 calibrations. The data log management folder is used to view, export, or delete a data log. An inserted USB drive into any available port is used to transfer the data in a CSV Excel format from the log to a PC. Calibration menu allows the calibration of the electrode and the titrants. All of the information regarding these calibrations is stored in the data log and provides accuracy and confidence in the measurement. The system settings include easy access to enter in operators, network the titrator, set up security functions, and edit the application to meet a variety of customer needs. The maintenance functions include tracking and scheduling maintenance on a variety of titrator components, such as the syringe, the pump, the electrode, stir, and reagents. The complete system can be operated and maintained through this simple software interface. The AT1000 was designed to be simple and ready to use. Once the titrator has been set up with the titrant, reagents, syringe, electrode, sample, and application loaded, the titration is easy to perform by selecting Start. This easy operation is because the loaded application directs the titrator to dispense the titrant accurately, add necessary reagent, determine the inflection or endpoint, and calculate the result automatically. The results are then stored in the data log for easy transfer and traceability, all leading to improved result reproducibility, accuracy, and productivity.